Hi, today we're going to be learning about factorizing algebraic expressions with difference of two squares. When you're going to factorize an algebraic expression that has difference of two squares, you first need to know how to identify it. So you need to know that it must have two terms only. There must be a minus sign between those two terms because it's the difference of two squares, and difference means minus. And then the terms must both be squares. Now, examples of squares could be your square numbers, 1, 4, 9, 16, and so on. It could also be fractions that are made with those square numbers, so that the square numbers could be in the numerator or in the denominator of the fraction. You can also have variables and brackets that have even exponents, but the exponents have to be even, otherwise it's not a square. Examples could be x squared, x to the power of 4, a squared, b to the power of 6, x plus 2 in brackets squared, a minus b in brackets to the power of 4, and so on. As long as all of the exponents are even, you can't have even exponents and odd exponents as well in the same term, then it's not a square. So every single exponent has to be even, and then it is a square. Okay, you can also have combinations. So for instance, you can have numbers like 4 and then variables x squared y to the power of 8, or you could have 9, which is a perfect square, and then your bracket x plus y all to the power of 4, or you could have 25 a to the power of 4 and then brackets a plus 2b all squared. So you can have combinations of your square numbers and your variables, and you can have brackets as well, as long as your variables and brackets all have even exponents and your number is a perfect square. Then you can use difference of two squares if you've got two terms and they are being subtracted. Okay, so now let's go and have a look at how you actually factorize algebraic expressions that have difference of two squares. Okay, so the first thing you're going to do is you're going to write the expression as a product of two brackets. So over here, if I've got a squared minus b squared, it's two terms, one is squared, the other is squared, and there's a minus between them. You're going to write it as a product of two brackets. In those two brackets, the first term is going to be the square root of the first term in the expression. So the first term in each set of brackets is the square root of the first term of the expression. So the square root of a squared is a. So that goes into both of the brackets. And then the second term in each of the brackets is going to be the square root of the second term of your expression. So the square root of b squared is b. So it goes b in the one bracket and b in the other bracket. And then the signs in your brackets, one must be a plus and one must be a minus. Now this may look familiar to you from when we were doing multiplication, when we were expanding algebraic expressions, that when you had two sets of brackets that looked the same except one had a plus and the other one had a minus, when you multiplied them together, we said that you square the first terms, you square the last terms, and you put a minus in between them. Now we're doing it the other way around. So that's where the difference of two squares factorization comes from. It's the reverse of that kind of multiplication where you had two brackets that were the same except for the plus and the minus. Then you squared the first to get the first term there. You had a minus, and then you squared the last term. Now we're doing it the other way around. We're factorizing. So we're taking this over here, which was our product, which is a square minus a square, and we're ending up with two sets of brackets which look the same except for a plus and a minus. And the terms inside the brackets have to be the square roots of the terms that we started with over there. Okay, once you've finished doing your factorizing here, you have to then check each bracket to see if it can be factorized further. Okay, so let's go and have a look at our first example for today. In this example, you've got 25 x squared y to the power of 6 minus 2 1/4. Okay, so let's have a look at how we would factorize this expression. So the first thing we're going to do is this 2 1/4 is a problem for me. I can't do anything with it as it is. I have to change that to an improper fraction. So 25 x to the power of 2 y to the power of 6 minus 2 1/4 is the same as 9 over 4. Now that is super important. Now I have difference of two squares. If you look at every single thing inside this expression, it's all perfect squares. I've got 25, it's a perfect square. I've got x squared, so this is supposed to be y to the power of 6 over here. X squared and y to the power of 6 both have even exponents. And then in this fraction over here, the numerator, 9, is a perfect square, and the denominator 4 is also a perfect square. So now I can use difference of two squares because I've got a term minus another term, and both of the terms are perfect squares. Okay, so what I'm going to do is I start off by opening two sets of brackets like this. Okay, in my brackets, the first term in each set of brackets is going to be the square root of the first term here. So I square root the number, 25 becomes 5. The square root of 25 is 5, and that goes in both. Then I do my x's. The square root of x squared is x. That goes in both. And then the square root of y to the power of 6 is y cubed. That goes in both. Okay, so your first term in each of the brackets is going to be exactly the same as each other, and it's the square root of the first term of your expression. Then one of the brackets gets a plus, and one of them gets a minus. I prefer to always put the plus first and the minus second, but it doesn't really matter. You can put them in any order. This is just the way I prefer to do it. Okay, then we're going to go on to our second term. 9 over 4, I need to square root. Now remember, when you square root a common fraction, you square root the top and the bottom of that fraction separately. So I square root the 9, that gives me 3. And that goes into this bracket as well. And that is over the square root of 4, which is going to be 2. So that is what you should get for that example. You've got two sets of brackets. The first term in each of the sets of brackets is the square root of the first term of that expression. The last term is the square root of the second term in the expression. And then one bracket gets a plus and the other bracket gets a minus. Okay, now I'm going to give you a few that you're going to do for yourself. Here's the first one that you're going to do. I'm going to give you 30 seconds to factorize this as far as possible. Okay, so let's go through that question quickly. So first you have to identify if this is difference of two squares. So I've got two terms, so that's check. Then both of the two terms are perfect squares, and there is a minus in between them. So this is difference of two squares. So I'm going to have two sets of brackets when I factorize, like that. The first term in each bracket is the square root of m squared. Remember, when we square root something with an exponent, we divide the exponent by 2. So I'm going to divide the 2 by 2, that gives me m. So the square root of m squared is m, and that goes in both of those brackets. Then the last term in each of the brackets is going to be the square root of the last term here. So the square root of n to the power of 4, again, I'm going to divide the exponent by 2. So that gives me n squared. And then my brackets get a plus and a minus. So one of them gets a plus, and the other one gets a minus. So that's what you should have got for that question. Now remember, I said it doesn't matter which way around you do the plus and the minus. You could have had minus and then plus. As long as you've got m plus n squared and m minus n squared in your two sets of brackets, they can be the other way around if you want. Okay, so that's question A. Let's go on to question B. I'm going to give you 30 seconds for this one as well. Okay, so let's go through that question and see what you should have got. Right, so first of all, I've got two terms. X squared is a perfect square, 9 is a perfect square, and I'm subtracting them. So this is difference of two squares. I'm going to start off by writing down my two sets of brackets. The square root of x squared is x. That's going to go first into each bracket, and then the square root of 9 is 3, and that goes second in each bracket, and then the brackets get a plus and a minus. that you should have got for question B. Right, let's go on to question C. I'll give you 30 seconds for this one as well. Okay, so let's go through that question. Right, so over here, again, we check that this is difference of two squares. 49 and a squared are all perfect squares. Then 100 and b squared are also. So I can start off by writing down my two sets of brackets. The square root of 49 is 7. And the square root of a squared is a. So I have 7a as my first term in each of the brackets. And then the square root of 100 is 10. And the square root of b squared is b. So I have 10b as the second term in each of the brackets. And then one bracket gets a plus and the other one gets a minus. Okay, let's go on to the next question. I'm going to give you 30 seconds for this one as well. Okay, so let's go through that question. Okay, so for question D, I've got a squared b to the power of 6, that is a perfect square, minus 1, which is a perfect square. So I have two sets of brackets. The square root of a squared b to the power of 6 is a b to the power of 3. We square root the a squared by dividing the exponent by 2. That gives me a to the power of 1, which we don't need to write. And then b cubed is the square root of b to the power of 6, because if I divide 6 by 2, I get 3. So I write that in both of my brackets as my first term. Then the square root of 1 is just 1. So that's going to be 1 over there and 1 over there. So I get a plus in one bracket and a minus in the other bracket. So that's what you should have got for question D. Right, let's go on to question E. I'm going to give you 30 seconds for this one as well. Okay, so let's go through that question. So for question E, we've got 64m squared n squared. 64 is a perfect square, and m squared and n squared both have even exponents. Then we've got 81, which is a perfect square, and p to the power of 8, where 8 is an even exponent. Okay, and I'm minusing. So this is difference of two squares. So I start off again by writing my two sets of brackets. The square root of 64 is 8. The square root of m squared is m, and the square root of n squared is n. So I get 8mn as the first term in each bracket, and then the square root of 81 is 9, and the square root of p to the power of 8 is p to the power of 4, because I divide that exponent by 2. So I get 9p to the power of 4 as the second term in each bracket, and then one bracket gets a plus and the other one gets a minus, and that's what you should have got for question E. Now let's go on to question F. In question F, you've got 25x to the power of 4 minus 4y squared over 49z to the power of 6. I'm going to give you 1 minute to factorize this expression. Okay, so let's go through that question. Right, so over here, 25 is a perfect square, x to the power 4 has an even exponent, 4 is a perfect square, y squared has an even exponent, 49 is a perfect square, and z to the power 6 has an even exponent. So I've got two terms that are both perfect squares, and I've got a minus. So this is difference of two squares. So I'm going to start off by putting down my brackets. Then I take my first term and I square root it. 25 square rooted is 5. And then the square root of x to the power 4 is x squared. So the first term in each bracket is 5x squared. Then I go on to the second term. Now this is a little bit more tricky just because it's a fraction. You have to do everything in this fraction. So the square root of 4 is 2. That's at the top. And the square root of y squared is y. Over the square root of 49 is 7. And the square root of z to the power of 6 is z cubed. So I have 2y over 7z cubed in each bracket. And one bracket gets a plus and the other one gets a minus. So that's what we should have got for question F. Right, let's go on to our next question. In this example, we've got 16x squared minus x plus 3 in brackets squared. Okay, so now this one's different because we've got this bracket which is being squared. So let's have a look at how we would do this question. Okay, so now first of all I check that this is difference of two squares. 16 is a perfect square, x squared has an even exponent, I've got a minus, and then my second term is a bracket with an even exponent. So this is difference of two squares, but I have to be more careful with this. Because of this bracket, I'm going to put in square brackets now, because I'm going to end up with a bracket left inside the bracket. So I want to just be able to see what's going on a little bit more easily, and that helps, and the square brackets help with that. Okay, so now let's go and factorize. So my 16, if I square root that, I get 4, so that's 4 in each bracket over there. Then the square root of x squared is x, like that. Okay, then I'm going to have the square root of x plus 3 squared. Now when I square root it, that square is going to disappear, but I'm still going to write it in brackets. X plus 3 and x plus 3. Okay, and then one of these is going to get a plus and the other one is going to get a minus. Now I need to go and get rid of the brackets that are inside the brackets. Okay, so I'm going to, over here, this is, because I'm going to be getting rid of these brackets inside, I can now change these to normal round brackets. So that's 4x, and then when I multiply this out over here, remember it's an imaginary little 1, you can't see it. So I'm multiplying each term by positive 1. Now when you multiply by positive 1, nothing changes. So it's positive 1 times x is plus x, and positive 1 times 3 is plus 3. Okay, but then in this one over here, this is where it was super important to keep those brackets, because here I'm multiplying in negative 1. Remember, when we multiply negative 1 by a number, the number is going to change its sign. So negative 1 times x and negative 1 times 3. And that's going to be different to what happened over here. So I have 4x, then minus x, and minus 3. And now I need to go and simplify what's inside these brackets. So I have 4x plus x is 5x plus 3. And then 4x minus x is 3x minus 3. Now, I can factorize this further over here. Because it's 3x minus 3, I've got a common factor. So I'm going to take that common factor out and put it right in the front over here. So 3 goes into both of those terms. So my common factor is 3. Then I've got 5x plus 3. And then in this bracket over here, I'm left with 3x divided by 3, which is x, minus 3 divided by 3, which is 1. So that's what you should get for that question. So when you've got brackets like this, you need to be careful. First of all, when you factorize it, use square brackets so that you can easily see the difference between the different brackets. And then keep the brackets around the term that was a bracket squared. Don't drop the brackets yet, because you're going to have to multiply it out. Then you're going to go and multiply it out and then simplify, and then you check if you can factorize what's inside the brackets that are left. I couldn't factorize this one. 5x plus 3 didn't have a common factor, but this one I could. 3x minus 3 had a common factor, so I had to take that out at the end there. Okay, so I'm going to give you a few that you're going to do for yourself. Here's the first one you're going to do. You've got x plus 2 squared minus 49. I'm going to give you 1 minute to factorize this question. Okay, so let's go through that example. Okay, so over here, I've got x plus 2 in brackets squared minus 49. Okay, so first of all, I'm going to start off by opening square brackets. I square root the x plus 2 squared. That just gives me x plus 2. And that is the first term in each bracket. Okay, then I have the square root of 49, which is 7. As the second term in each bracket. One gets a plus, the other one gets a minus. Now I can go and drop the brackets inside the brackets. So I'm going to have normal brackets now. In front here, it's just 1. If I multiply that out, the x plus 2 isn't going to change. Plus 7. And then the same thing over here. Because there's nothing in front of it, I can just drop the brackets and nothing changes. X plus 2 minus 7. And now we're going to go and simplify what's inside. So I've got x plus 2 plus 7. That gives me x plus 9. And then x plus 2 minus 7 gives me x minus 5. So that's what you should have got for question A. Right, now we're going to go on to question B. I'm going to give you 1 minute to factorize this as well. Okay, so let's go through that question. So I've got 100 minus my brackets squared. I'm going to start off by opening square brackets. I've got 100 square rooted gives me 10 in each of the brackets. Then I've got a plus and a minus. And then the square root of y minus 3 squared is y minus 3. And I keep those brackets. Okay, now I need to go and multiply out and get rid of the brackets inside. So I'm going to have 10. Then when I multiply this out, because it's just positive 1, nothing's going to change. So it's going to be plus y minus 3. But this one, it does change. So I've got 10. Then I'm multiplying negative 1 in here. So it's negative 1 times y is minus y. And negative 1 times negative 3 is plus 3. If you left out the brackets, you wouldn't have got the plus 3 here. Okay, now we're going to go and simplify. So I've got 10 plus y minus 3. That's going to be 7 plus y. And then 10 plus 3 is 13 minus y. So that's what you should have got for question B. Right, let's go on to question C. It should give you 1 minute to factorize this one as well. Okay, so let's go through that question. Right, so over here, I'm going to start off by opening my square brackets. Okay, so I factorized 25, that gives me 5, and then I factorized my bracket squared, that gives me 2x plus y. Then over here I have 5 and 2x plus y as well. Then I'm going to factorize, or I'm going to square root the 36, that gives me 6, and then square root the z squared, that gives me z. So over here that's also 6 and z. Then I'm going to have a plus in the one and a minus in the other. Now I can go and multiply out my brackets inside the brackets here. So that's going to give me 5 times 2x is 10x, and then 5 times y plus 5y, and then I've got plus 6z. Then over here I've got 5 times 2x as well, that's 10x. 5 times y is plus 5y, and then minus 6z. So as we should have got for question C. Now we're going to go on to question D. I'm going to give you 1 minute for this one as well. Okay, so let's go through that question. So here I'm going to again open my square brackets. I square root the 64, that gives me 8, and I square root b squared, that gives me b. So it's 8b in each bracket. Then I've got 3b minus 1 squared, so I'm going to square root that, gives me 3b minus 1. And one bracket gets a plus and the other one gets a minus. Now I'm going to go and get rid of the brackets inside the brackets. Okay, so I've got over here 8b. Then when I multiply this out, 3b minus 1 isn't going to change because it's just a plus in front. So plus 3b minus 1. Then over here, I've got 8b as well. But now when I multiply in, I have negative 1 times 3b is minus 3b. And then negative 1 times negative 1 is positive 1. So now I can go and simplify this. I've got 3b plus 8b. That gives me 11b minus 1. And then here I've got 3b minus 3b, or 8b minus 3b is 5b, and then plus 1. So that you should have got for question D. Okay, let's go on to our next example. In this example, we have to factorize as far as possible. I've got x to the power of 8 minus 1. Okay, so let's have a look at how we would do this question. Okay, so over here, it starts off as a normal difference of two squares question. So I have x to the power of 8 minus 1. I open my two sets of brackets. I square root x to the power of 8. That gives me x to the power of 4, and it goes into each of the brackets as the first term. Then I square root the 1, and I get 1, and that goes is the second term in each of the brackets. One bracket gets a plus, and the other one gets a minus. Now this is where it comes in where I said I prefer to do the plus first and the minus second. The reason is because now I've got x to the power of 4 minus 1, which I can still factorize further. I can't factorize this one because it's got a plus, but this one is two terms with a minus in between. This has still got an even exponent, and that is still a perfect square as well. So this is difference of two squares again, so I can still factorize that further. I prefer to do the plus first and then the minus because this is just going to carry on coming down until I'm done. But this one is going to carry on getting factorized. So let's go over here. This doesn't change. So I have x to the power of 4 plus 1. Then over here, x to the power of 4 minus 1, I'm going to factorize. I'm going to get 2 sets of brackets again for that one over there. So the square root of x to the power of 4 is x squared. And that goes into both of those sets of brackets. Then the square root of 1 is 1, and that goes into both of those sets of brackets. And one gets a plus, and the other one gets a minus. Okay, now if you look over here, I still can't factorize this further. But this one I can still factorize further. So now I'm going to go and do it again. So this is just going to come and not change. X to the power of 4 plus 1, I just bring it down. The x squared plus 1, I just bring it down. And I write it down as it is. But then this one, I'm going to go and factorize further. So I open 2 sets of brackets again because it's still difference of 2 squares. X squared minus 1 is going to factorize to give me the square root of x, which is, the square root of x squared, which is x, and x over there. And then the square root of 1, which is 1 and 1. 1 gets a plus, and 1 gets a minus. And now if you check it, I've got x to the power of 4 plus 1. I can't factorize that further. X squared plus 1, I can't factorize further. X plus 1, I can't factorize further. And this one, x minus 1, I now have reached the point where I can't factorize it further, because even though it's a minus, and that's a 1, which is a perfect square, the x does not have an even exponent. It's got an odd exponent now, so I can't square root that, so I can't factorize that further. So now I have factorized as far as possible. I'm going to give you a couple that you're going to try for yourself. So here's the first one you're going to do. You've got 16x to the power of 12 minus y to the power of 8, z to the power of 16. I'm going to give you 1 minute to factorize this expression as far as possible. Okay, so let's go through that question and see what you should have got. Right, so we start off by checking that this is difference of 2 squares. 16 is a perfect square. X to the power of 12 has an even exponent. And then y to the power of 8 and z to the power of 16 also both have even exponents. There are 2 terms with a minus in between. Okay, so I'm going to start off by opening my 2 sets of brackets. The square root of 16 is 4. The square root of x to the power of 12 is x to the power of 6. Then over here, the square root of y to the power of 8 is y to the power of 4. And the square root of z to the power of 16 is z to the power of 8. One bracket gets a plus and the other one gets a minus. Okay, so this is supposed to be x to the power of 6 over there. Okay, so now we can go and factorize further, because if you look over here, I can't do anything with this, but this one, 4 is still a perfect square. X to the power of 6 still has an even exponent, y to the power of 4 still has an even exponent, and z to the power of 8 still has an even exponent. So this is all perfect squares, and there's a minus between them, which means it's still difference of 2 squares. This one, even though it's all perfect squares, there's a plus, which means it's not difference of 2 squares, it's the sum of 2 squares, and I can't factorize that. So this is going to stay as it is. I just bring it down. But this one, I can factorize further. So I have 2 sets of brackets. The square root of 4 is 2. The square root of x to the power of 6 is x cubed. Then over here, the square root of y to the power of 4 is y squared. And the square root of z to the power of 8 is z to the power of 4. And one gets a plus and the other one gets a minus. Now over here, this is already factorized as far as possible. This one, I can't factorize further as well because it's a plus. And then this one I also can't factorize further, even though it's a minus, and these are all even. That exponent is odd, and this is not a perfect square either. So I've now factorized that as far as possible. So that's what you should have got for question A. Right, let's go on to question B, which is the last one for today. I'm going to give you 1 minute to factorize this as far as possible. Okay, so let's go through that question and see what you should have got. Right, so over here, I've got 1, which is a perfect square, minus a to the power of 20, b to the power of 8, which is also a perfect square. So now we can go and factorize this by putting down our 2 sets of brackets. The square root of 1 is 1. The square root of a to the power of 20 is a to the power of 10. And the square root of b to the power of 8 is b to the power of 4. One of the brackets gets a plus and the other one gets a minus. Okay, now over here, this is still difference of 2 squares because I can square root the 1 and the a to the power of 10, b to the power of 4 again because those are even exponents, and this is a minus over here. This I can't do anything with because it's a plus, so I just bring it and write it down as it is. Okay, then I open my new brackets over here. So I've got the square root of 1 again is 1. Then the square root of a to the power of 10 is a to the power of 5. And the square root of b to the power of 4 is b squared. And 1 gets a plus and 1 gets a minus. Now I can't factorize any further. This I already couldn't because it was a plus, and this also is a plus. Then this one over here I can't factorize further because even though it's 1, which is a perfect square, and minus, over here that's an odd exponent. So that means that I can't do difference of 2 squares again. Okay, and that's what you should have got for that question. And that is how we factorize algebraic expressions with difference of 2 squares. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.